Hi guys, welcome to Little Wicket Railway. I'm Rob, and in this video I'm going to walk you through how to build a digital base station that you can use with your computer to control your digital layout without any soldering, and all for under £40. Running a digital layout can give you a lot more options and be a lot more fun. So maybe you're like I was, starting from scratch and you want to go with digital from the beginning, or maybe you've got an existing analog layout that you're thinking about converting. Either way, you're going to need a controller. Even the basic digital controller from Hornby costs more than £100, and more sophisticated controllers can cost a lot more than that. Just think of how many models you can buy for that money. So when I saw this, I was really put off, until I found the DCC++ base station. There's already quite a bit of documentation out there on how to set this up, but I will admit I still struggled when I did this. So I wanted to put together a step-by-step guide on how to do this, from the beginning, buying the components, through to setting up and to running a train. To make things easier, I've listed all the steps as chapters in the description, so you can click on those and jump around if you need to. I've also put links to all the components you need and where you can buy them. Please let me know in the comments if any of those links stop working, and I'll try to keep them updated. Please give this video a like if you find it useful, and please support the channel by subscribing. Right, let's get started. These are the components you need to build your base station, and all the links to where you can buy them are in the description. The main ingredient is an Arduino, or a generic brand version of an Arduino. In this video, we're using a product from a company called Eligu, but it's identical to an Arduino. If you've not heard of Arduino before, then it's an open sourced electronics platform based on easy to use hardware and software. It's intended for anyone making interactive projects. You can do loads of cool stuff with them, and I use them for monitoring my sensors and controlling servos. There are different types of Arduino, but in this video we're using the Uno R3 version. You can pick this up individually on eBay or Amazon for around £10. However, you can also buy starter kits which come with loads of accessories and teach you how to use Arduino in a variety of projects. If you think this might be of interest to you, then it can be more cost effective to buy the set rather than the individual Arduino, and you get loads of other electronic components at the same time. You'll also need a USB cable to connect it to your computer. The cable that comes with the Arduino is a little bit short, and my base station is quite far away from my computer, so I'm going to have to use a longer cable. The next item you'll need is a motor shield. Again, if you're new to Arduino, then the shield is just a board that plugs directly on top of the Arduino and gives it extra functionality. There are loads of different types of shields available depending on what you intend to use the Arduino for, but we need a motor shield, and I'm using an L298P. Again, this is available from eBay or Amazon for around £10. Next, you'll need a power supply. You can use the standard Hornby power supply that comes with the newer controllers. These are 19 volts and half an amp. If you're looking to run larger layouts with lots of locomotives running at the same time, then that current might not be sufficient, and you'll probably want something a bit more powerful. Laptop power supplies are ideal for this, so I picked up a 19 volt supply that gives out 3.4 amps, and that will comfortably run a few locomotives at the same time. You can pick these up from Amazon or eBay for less than £15. This one has a barrel connector on it with a 5.5mm outer diameter and a 2.5 inner diameter, which is important for our next item. A plug socket that can be used with your power supply to connect it to the Arduino. It's optional, but it means you don't have to chop the end off your new power supply, and the power supply can be easily disconnected from the base station. I have a cable like this that runs from my base station to the edge of my baseboard, where I've mounted the socket so that I can easily disconnect from the power supply. Again, this will only cost a few pounds on Amazon or eBay, but it might make your life a bit easier. Wires. You're going to need 2 sets of longer wires to connect your baseboard to your tracks, and 2 short jumper wires to connect pins on the motor shield. Wiring a digital layout is a much debated subject and something you should read into before permanently connecting up your track work, but it's beyond the scope of this video, and we're going to keep it simple by using just a few wires to connect to one place on our layout. The main thing is that you make sure the wires are suitable for the maximum current you intend to use and the power supply. Wires shouldn't cost more than a couple of pounds. Finally, you're going to need to download the Arduino software, which is free, and the JMRI software, which is also free. Now, I think you can get all of that for less than £40, but you are going to need a few other things to help you build it. The first thing that's essential is a computer. It doesn't have to be the best computer in the world, but it does have to be able to run the Arduino software and JMRI. The next thing that's essential is a flathead screwdriver for connecting wires at the terminals. Something that might be useful is a craft knife. Depending on your wires, you might need wire cutters or wire strippers. A multimeter is useful to have just to double check that everything's working and can be used for fault finding. You're going to need a short section of track or a rolling road, which we can use as a programming track. And if you don't know what a programming track is, don't worry, we can cover that later. And you're going to obviously need your layout with a power connector. And the power connector we're using is one of the Hornby slide-in ones, but the only difference is that it's got DCC written on the back. And all this means is that inside, where there would usually be a capacitor, that they've cut that out. So if you've got an analog one and you want to convert it into a DCC power connector, all you need to do is open it up and chop out that capacitor. And the final thing you'll need is a locomotive that is fitted with a digital decoder. I've broken this process down into 13 steps, and I've listed them all as chapters in the description below, so you can click on the links and it will jump to the right point in the video. So if you need to come back to this later, you can do. Finally, a reminder to take care because you're working with electricity and the usual risk supply. The voltages and currents we're working with are pretty safe, but please follow the instructions carefully and take basic safety precautions to prevent damaging the sensitive electrical components or causing yourself injury. You should disconnect the power supply whilst assembling your base station and consider using a residual current device when you plug your power supply into the mains. The DCC++ base station also has short circuit detection built in and will turn off power to the track if detected, but any kind of short circuit should be avoided. Step 1 is to install the Arduino software. So we need to go to arduino.cc in your browser, go to software and downloads. And then if you scroll down, you need to select your operating system from the list. I'm using Windows 10. It gives you the option to donate and fund the project, and they are giving you something for free, so you maybe consider it. And then you click just download. It's quite a large file, so it could take some time, so we're going to fast forward through this bit. Once it's downloaded, click on the executable, read your terms and conditions and licenses, click through the installation screens and choose a folder and hit install. So again, this could take some time, so we're going to fast forward through this. You'll potentially see a few of these Windows security warnings. This is safe, so you can install this. So we're going to open up our Arduino. There's the short cable. Here's the Arduino. Take that out. So there's your USB. So connect your cable. As I say, this one's a bit too short for me, so I'm using a slightly longer one. And take that and just connect it to the computer. You should see lights come on. We need to download the DCC++ program or sketch that you're going to upload into your Arduino. And this can be found at github.com/DCC++. Once you're in here, you need to go to the base station area. If you click into that top folder, you'll see there are loads of files, and these have all been created by a guy called Gregg Berman, who is the creator of DCC++. We need all of these files, so if you come up a level and click on that green download button to download the folder, select zip, it'll start downloading, it'll be really quick. Once it's there, you can open it up and extract it to somewhere where you'll be able to find it. I think for now I'm just going to store this on my desktop. Now we're going to upload the program or the sketch into the Arduino. So open the folder that you've just extracted and find the dcc_pp_uno.ini file. If you double click on that, it'll open it in the Arduino software. The first thing we need to do is check that the Arduino software can see the Arduino we've got plugged in. So if you go to the Tools menu and scroll down until you see the Board section and make sure that Arduino Uno is selected. Next, if you go to the port section, you need to check that the Arduino Uno is connected on one of your ports. Your computer will have automatically assigned a COM port to the Arduino. In this case, it's COM5, and you'll need to know that for later on. To check that you've got all the files you need, you can click on this little tick in the top left-hand corner, and that will compile the sketch to check that it's all valid before you can upload it. This little green progress bar tells you how it's doing, and then in the bottom left, it gives you the status. And then once you're happy, you can click on the little arrow button in the top left, and that'll upload it to the Arduino. And there's success, done uploading. So before we can plug the motor shield into the Arduino, we need to do something to it to stop it from damaging the Arduino. And there's a guide to this on Gregg Berman's DCC++ website. So if we go to github.com/DCC++ again, and this time we're going into the repository section and click on documentation. And there is a PDF for the motor shields in here. And we want to scroll down until we get to this section about disabling the VIN connect. So the motor shield would normally pass the power it receives from the power pack into the Arduino, but the voltage we're using is too high. So we need to break this little connection to stop that from happening, because it would damage the Arduino. Currently that's connected because there's no resistance between the two contacts. So we need to take our craft knife and just scrape away and break that connection. Okay, that looks like it's broken, but we can double check. This is where the multimeter comes in handy again. So if we put our contacts on these two areas again, it should show that the resistance is 1, which means that we've successfully broken the connection. Okay, so we've uploaded the sketch onto our Arduino. We can disconnect that, and we're ready to put the motor shield on top with our disconnected contact there. So this literally just sits on top. So these pins there align with pins there. So if we can fit those in, then it's just a case of pushing it together. This one doesn't go all the way down because these contacts are stopping it, but hopefully those are in enough to make contact. Okay, the next thing we need to do is to connect some of these. These are pins, and you can see, if I can focus, these are numbered. So they go from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and then you've got ground and a few other bits and pieces. So we need to connect pin 13, which is this one here, with one of our wires, and we're going to connect that to pin number 5, which is this one here. And then we're going to connect pin 12 to pin 10, which is this one. So these pin connections are in the documentation on the DCC++ repository. So that is it all wired up. The next thing we need to do is connect our wires that are going to go to the track and the power supply. So the power supply is going to come into here, and the feed to the track are going to come out of here. So these top two are going to go to the thing called the programming track, which is where we can program our decoders for our locomotives. And these middle two are going to go to our main operations track. So that's your main layout. So let's start by connecting those. And it's just a case of taking the wires that you've got and a screwdriver and just clamping those in. So let's start with the ones for the operating track. That should just slide in. We can tighten that one up. And then this next one, make sure that's for the wires for the tracks. It doesn't matter which wire goes in which terminal. The way digital works means there isn't really a positive and negative. Just goes into there. And now we're going to attach the wires for the programming track. So same procedure, but the other side, just break these apart. So make sure these are undone. This wire goes in first. This wire goes in next. Make sure those are all in nice and tight. So that's the wire that's going to go to our programming track. And now we're going to attach the power cable. Okay, so here we've got our laptop power supply and we somehow need to fit this into there. Now we've got two options. We can either chop the end off here to expose the wires, but I don't like to do that because you might want to use this for something else in future. So that's where our optional extension cable comes in. So it's got the plug on there, so this would fit into here, and then these then are able to be screwed into there. Now the benefit of this is you can leave this cable permanently attached to your base station, and then this can just plug in and plug out. So in mine, my base station's in the far corner with this attached to it, and then this runs under the baseboard to the edge where I can just plug in and out. Most power supplies will tell you whether the inner wire is positive or negative, but we can use our multimeter again just to double check. So here you can see my inner wire is positive because the number on the multimeter is positive, and my outer wire is negative. Here it's putting out slightly more than the advertised 19 volts, but that shouldn't be too much of a problem. We've got V in here, which is our positive, and we've got ground here, which is our negative. So I'm going to go and pop these in. Close together. So now we are all wired up. Now we need to head over to jmri.org in your browser to download the software which is going to work with the base station to control your layout. The first thing you need is Java to be installed. I won't show you how to do that on here, but you will need it to be installed to run JMRI. So once you're on the JMRI site, you need to scroll down to the latest production release, select your operating system, and that will start to download. JMRI is another fantastic open source project that is continuously being developed by a community of people. It is so powerful. You can do everything in here, from simply running a train to connecting it to your phone to run a train, to operating your points, your signals, and even doing automation. You might get the usual Windows security things, so we're going to say run anyway. Click through all the installation screens. And we're ready to move on to the next step. Now we're ready to connect the base station back up to the computer and to our track. So insert the USB cable again. Next you can take the wires out of the terminal labelled B and connect those to your programming track. In my case I'm using the rolling road. Take the other set of wires that come out of the terminal labelled A and connect those to your power connector and into your main layout track. Finally, reconnect your power supply. Before we can start using the base station, we need to configure it in JMRI. So double click on the Panel Pro icon and that will start the program. Once it's open, you need to go to the Edit menu and select Preferences. The top option in preferences is connections, and this is what you need to change. So under system connection, you need to change it from DCC++ simulator to DCC++ serial. Then from the settings below, you need to select your serial port, and this will be the same COM number that your system allocated the Arduino board when you uploaded the sketch. So in my case, it's COM5. Then you need to click the save button, and the system will say it needs to restart. Now here comes the exciting part. We're going to add our first locomotive to our list of locomotives called the roster. So double click on Panel Pro and open JMRI, then go to the roster menu and click on roster. This opens your roster, which is going to be a list of all your locomotives. We need to place our model on our programming track. So I'm going to put my 4P compound on the rolling road. Next we need to turn the power on, and you should see lights come on your Arduino. Then you need to click on the big plus that says New Loco. This is going to open a screen where you tell JMRI what type of decoder is in your model. And JMRI is really clever because it can actually try to work this out itself if you click on the read type from decoder button. And if everything's working correctly, your locomotive will start juddering as JMRI is reading the information from the decoder. JMRI has actually detected I've got a coronation class sound decoder in mind, which is right because I was trying that out. It's also detected that this locomotive already has the address of 10. Each locomotive needs a unique DCC address. We don't already have a locomotive with a DCC address of 10, so I'm fine to leave it as that, but you could change it to be any number between 1 and 255. You just have to make sure that it's unique to that locomotive. So we can give this new locomotive a name. And there you see our test locomotive has appeared in our roster. So now we can turn the power off and move the locomotive from the programming track onto the main operations track. And now for the really exciting part, we're going to run our first locomotive. So we need to open JMRI, click on Tools, Throttles and New Throttle. This is going to bring up the panel we need to control our locomotive. From the address panel, we need to select our compound from the drop-down box, and it's showing address 10, which is the one we gave it. Next, we need to turn on our power, and then using the slider on the left, let's turn it up to just over 50%. And there we go, our compound's moving around the track. So if your locomotive has functions on it, so this one's a sound decoder, we can turn those on using the function keys. So let's turn on the main locomotive sound. And we've got the horn here as well. We've got other functions that you can use. Okay, let's slow this down. And bring him to a stop round the back. Now I want to show you one of the main features of having a digital layout, and that's that you can run two locomotives on the same track at the same time, completely independently of each other. So what we're going to do is go to our roster and add another locomotive in the same way that we added the first one. So we've got our little Jinty here on the programming track. This one's got a DCC concepts decoder in it that JMRI doesn't recognise immediately, so we have to add that. But it has picked up that it's already got the address of 8, so let's give it a name, click save, and it appears in our roster. So this means when we open a throttle, we'll be able to select the Jinty from there. So let's open a couple of throttles, one for our compound, and move this one over here. And we'll open another throttle, one for our Jinty. So let's select those from the drop downs. This one on the left can be for the compound, and this one on the right can be for the Jinty. Let's turn the compound up to a slow speed and put the Jinty on a slow speed, and there they are. And these are running completely independently of each other based on what inputs we're putting into their respective throttles. So we can make the compound a bit faster because the Jinty was catching it. You probably wouldn't want to run multiple trains on a small layout like this, but on a larger layout, this allows you to do realistic train operations. Let's bring both of them to the stop, and just to show you, you can put one in reverse. Oh, our Jinty's got stuck. Let's give him a bit of a nudge. So there he goes, running backwards. And at the same time, we could have been running the other locomotive forwards. So let's close those. And you can repeat that process for as many locomotives as you want, adding them to your roster and opening a throttle for them. Thanks for watching. I hope you found that useful and you're now enjoying your new digitally controlled layout. If you've got any questions or suggestions, then please stick them in the comments below and I'll try to respond. If you like this and want more of the same, then please subscribe to the channel and I will hopefully see you again here very soon.